Remember that we can graph any two things that are related to each other. So when we're looking at videos, a lot of times we're going to relate the time of the video with something that's happening in the video. Maybe you're graphing how close something is to the camera. Maybe you're graphing how close two people are to each other. Maybe you're graphing how high something is. Maybe you're graphing how loud something is or how fast something is. All of those things can be graphed with relation to time. And so our x value is going to be time in most of these video examples, and then our y value can be anything. In my case, it's going to be height. So I was going to record like a super awesome video of me like walking over some rocks, but I didn't get a chance to. So just imagine in your brain that I made that awesome video, and we're going to analyze it. So here I am. I'm going to take a little walk. And it's over like a really rocky area. So, wow, that's a lot of hair. Okay. It's over a really rocky area, and my walk takes exactly 15 seconds for me to complete. And let's see what happens on my walk. So first, I go up this really big hill, and then I come back down. And then there's a little rock that I go up. And then I come back down, and when I come back down, there's actually a hole in the ground. There's like water in a puddle, and I can't resist because, you know, I'm a boy mom, and we splash in every puddle. So I'm going to go down in that puddle, and I'm going to walk in that puddle for a little while, and then I come back up, and I end at the top of a small hill. All right, there's my beautiful walk that I did. Now let's analyze this for all of the key features of a function. First, let's look at the domain. So remember, domain, we can decide what domain is by drawing a box around our function. So we can draw a box around this. Let's actually fix that. It should come down like that into the puddle, and then we'll go back up. There we go. Oh, I keep missing where I'm trying to hit. There we go. Okay, so we're going to draw a box around this. Let's see. We're going to draw right here and here, so we got to encompass the entire function in our box. So what is the domain? Well, the farthest left that we go, when did we start the video? When did this whole graph start? Well, this whole graph started at 0 seconds. And when did the video end? Well, it ended at 15 seconds. Okay? And then range tells me how far I went, how low I went, and how high I went. So what's the lowest point that I hit? Well, I hit -2. At least I tried to. My graph didn't get quite there, but we got that. You understand. And then the tallest I went was 4, so I went all the way up to 4 feet. So the domain tells me that I started the video at 0 and ended the video at 15 seconds. The range tells me that the lowest point on that I went was -2 feet, and that the highest point that I went was +4 feet. So this was a crazy 15-second walk. All right. Now we're going to look at positive and negative intervals. So imagine, well, you don't have to imagine because I told you the story. I was walking above the ground. Now remember, we're talking about where my feet are. So my feet here are above the ground. And then right here, this is where my feet went below the ground, right? So let's highlight. We have above the ground. This is my positive. And then below the ground, this is my negative, right? So at what time was I above the ground? What time on the video was I above the ground? Well, that interval would be, oh, wrong pen. Oh man, okay. Positive. What time did I start being above the ground in my video? At 0 seconds, I was above ground, right? And then at 10 seconds is where I ended being above the ground. So the interval that I was above ground tells me what time I started having positive and what time I ended being positive, right? And then when was I negative? Well, I was negative right here from 10, and I highlighted too far, didn't I? From 10 to 14. From 10 to 14, remember that's what interval notation means. I was negative. And then let's fix that highlighting right there. That should be positive right there. So I was also then positive from 14 seconds to 15 seconds. I was also positive. So these are my positive and negative intervals. Now, let's see if we can get our increasing and decreasing. So I'm increasing when I'm going up the hill, I'm decreasing when I'm going down the hill. So what time in my video was I going up the hill? Well, let's see. I was going up the hill here, then I stopped going up and I went down, and then I went up a hill here, right? And then I went up a hill here. So those are all my increasing. And then my decreasing, let's see, I was going down a hill there, I was going down a hill there. Okay, so what time on the video was I increasing? Well, I was increasing from 0 to 4, and from 6 to 8, and from 12 to 15. And when was I decreasing? From 4 to 6, and from 8 to 12. So remember, this is just interval notation, and what it means is from 0 to 4 seconds I was increasing, from 6 to 8 seconds I was increasing, and from 12 to 15 seconds I was increasing. So the next thing we're going to look at is intercept. Our x-intercepts tell us where it crosses the x-axis. Our y-intercept tells us where it crosses the y-axis. So let's take a look. We cross the x-axis here and here. So what does that mean? My x-intercepts are at 10 and at 14. What does that mean? Well, that means that I went from being above ground to being below ground, or vice versa, right? So I crossed the ground at some point, the ground level at those points. So at 10, I went from above to below, and at 14, I went from below to above. And my y-intercept, I only have one y-intercept. It's right over here, and that's at 0, 0. And that tells me that at time 0, I was at height of 0. Okay, and that's all the key features of the function except for average rate of change. So let's take one look at average rate of change. Average rate of change over an interval says from this time to this time, how much did I change? And I know it can feel really, really complicated because it's just not as intuitive as you think, but let's try. So let's imagine from this peak to this peak, I want to see what's the average rate of change from 4 seconds to 8 seconds in my video, okay? So basically I'm trying to figure out from this point to this point, what's the slope in between those? How much did I change in the y, and how much did I change in the x? That tells me on average in those 4 seconds, this is how much I changed, okay? So remember that to find the slope of a line, all we do is we count the change in the y over the change in the x. So we can do that here. From this point, how much did the y change if I'm trying to get down to that point? I went 1, 2. I went down 2, right? So my change in y was 2, negative 2, because I went down 2. Change in x, let's see, how many did I go over? 1, 2, 3, 4. So I went over 4. So my change in y divided by my change in x is negative 2/4, which is also negative 1/2. So my average rate of change is negative 1/2, which basically means that over this time from here to here, I changed about 1 foot every 2 seconds, or 1/2 of a foot every second. So basically, to find average rate of change, all you do is you draw a line in between the 2 points, and then you find the slope of that line. And one more thing, to find the slope of that line, I want you to remember that you can do exactly what I did. You can just count, but sometimes you can't remember how to do that, so that's fine. So we have change in y, which is, remember, y2 minus y1, over the change in x, which is x2 minus x1. So it's how much did they change. So there you go. There's all your key features of a function.